Today's lesson has to do with dilation. For dilation centered at the origin, you can find the image of point x, y by multiplying the coordinates of p. And you notice here's the dilation, here's the factor, so you multiply n times x and n times y, so that's the rule. And you can see the image here. This is the point, and so to find p prime, it's going to be n times x and n times y. So you're multiplying the x coordinate and the y coordinate by a scale factor. In this case, it's n. Problem number 1, multiple choice, is D, and we have the scale factor in x. And enlargement or reduction. What is the scale factor of n of the dilation? So you notice here's a triangle, XRT. The length from x to t is 4. And the length from x prime to t prime is 4 plus 8, which is 12. So if we use a ratio of x prime t prime to xt, we have 4 plus 8, which gives us 12 over 4. You know the scale factor is 3. So x prime, t prime, r prime, that triangle is an enlargement with a scale factor of 3. And we look at problem 2, it says finding an image. What are the coordinates of vertices of, and then the dilation is 2. So it says identify the coordinates of each vertex. The center of dilation is the origin. The scale factor is 2. And you notice that we're multiplying each coordinate by 2. We need the coordinates of p, the coordinates of z, and the coordinates of g. And here is the pre-image, and here is the new image. For number 7, it says write the coordinate rule that describes each dilation. Use a rule to find the images of the vertices of triangle PQR for each dilation. So we have D, and we know that the scale factor is 10. So what's going to be the rule? 10x plus, 10x. So it's 10 times the x coordinate and 10 times the y coordinate. For example, this is negative 1, 2. Negative 1, 2. So where is Q prime going to be? Negative 10, 20. R is 1, negative 3. So where is R prime? It's going to be 10, negative 30. And then P is negative 5, 1. So P prime will be a negative 50, comma 10. And all I did was multiply by 10. We're still talking about dilations, the enlargement, or reduction of a figure. The scale factor indicates how much the figure will enlarge or reduce. The variable for a scale factor is k. When k is larger than 1, then dilation is an enlargement. When k is less than 1, it's going to be a reduction. So you need to understand that a dilation can either be it could be an enlargement or reduction. So we're going to go ahead and do number 1. And we know that the scale factor is 2, so we're going to go ahead and graph the triangle. Make it larger here. So that's R. S will be negative 3, 4. And T is going to be 2, negative 1. So we know the scale factor is 2, so to find r prime, it's going to be 2 times negative 5, comma, 2 times 1. So it's going to be negative 10 to s prime, 2 times negative 3, and then 2 times 4. So it's negative 6, 8, and then t prime is 2 times 2, 2 times negative 1. So it's going to be 4, negative 2. So r prime is negative 10. So I'm going to go ahead and graph the enlargement. So we have negative 10, 2. That's r prime. That's s prime. And this enlargement is over the origin. So that's going to be the enlargement. We're going to go ahead and do number 2 now. And it's a rectangle, so let's go ahead and graph the vertices. So first is negative 3, 0. 1, 2. 2, 0. And this is D. Negative 2, 2. Negative 2, negative 2. We know that the scale factor is 3, so it is an enlargement. So to find A prime, we're going to get 3 times, we're going to multiply 3 times negative 3, comma, 3 times 0. So we get negative 9, 0. So that's negative 9, 0. B prime is 3 times 1, comma, 3 times 2. So that's going to be 3, 6. 3, 6. 2, 3, 1, 2, 3, 4, 5, 6. That's B prime. C prime is going to be 3 times 2, comma, 3 times 0, which will be 6, 0. 6, 0. That's C prime. And of course, D prime will be 3 times negative 2, comma, 3 times negative 2. So we get negative 6, negative 6. And that's D prime. So this enlargement is over the origin, right? Once again, let's go to number 4. And you notice it's a fraction. It says triangle XYZ with vertices negative 4, 8, 10, 0, negative 2, negative 8. We're going to graph that. But you notice that the scale factor is 1/4. So this will be a reduction. So we have negative 4. That's W. Y is negative 2, 3, 4, 5, 6, 7, 8. That's Y. negative 2, negative 8, and then 10, 0. This is 10, 0. So I'm going to go ahead and connect the points. So we know that W prime is 1/4 times negative 4, comma 1/4 times 8. It's negative 1, 2. We have 1/4 times negative 2, comma 1/4 times negative 8. Well, this is negative 2, and this is negative 1/2. And this is y prime, negative 1/2, negative 2. So we know that x prime, the second one is 0, because 0 times 1/4 is 0. And then 1/4 times 10. This will be 10 over 4, which reduces to 5 over 2, which is 2.5. 2.50. So I'm going to go ahead and graph this. I'll use black. So negative 1, 2. That's W prime. X is 2.50. That's x prime. And negative 1/2, negative 2, that's going to be y prime. And there is a reduction over the origin. So we have a rhombus, and we notice that we have a fraction which is 1/4 or 1/2. So let's go ahead and graph our vertices. So J is going to be negative 10, 2. K is negative 2, 8. L is going to be 6, 2. And M is negative 2, negative 4. So now we're going to multiply times 1/2. So we have J, and we have 1/2 times negative 10, comma 1/2 times 2. That's J prime. K prime is 1/2 times negative 2, comma 1/2 times 8. L prime, 1/2 times 6, comma 1/2 times 2. And then M prime, 1/2 times negative 2, comma 1/2 times negative 4. So J prime, 1/2 of negative 10 is negative 5. 1. 1/2 of 2 is 1. 1/2 of negative 2 is negative 1. 1/2 of 8 is 4. 1/2 of 6 is 3. 1/2 of 2 is 1. 1/2 of negative 2 is negative 1. 1/2 of negative 4 is negative 2. So I'm going to graph this negative 5, 1, J prime. That's J prime. Negative 1, 1, 2, 3, 4. That's K prime. 1, 2, 3, 1. That's L prime. Negative 1, 2, and that's M prime. And there is my reduction.